Live streaming is on.
I'm sorry, Jace, what was that?
I said this is why you divide the person doing the recording with the person introducing the person.
Yep.
I have a question.
So, all right.
My question is, who actually invested in OpenAI? Is it Google or is it Microsoft?
Neither. Well, everybody's invested,
Others, right?
but it's a new company called OpenAI, founded by Sam Altman, and he's been all over the radio waves promoting it. But they've got a great lead, but open source AI is coming up right behind them so fast that they might not last another month.
Oh, cool.
Yeah, so it's kind of panning out like the original internet did.
I mean, Microsoft is funding them. They're getting Azure credits. That's where all their inferences and everything run. So they are supported by Microsoft, which is why you had the Bing thing, but not Google. Definitely not Google now.
It was hard to hear you on that one, Andy. So I think you're being hampered by the windstorm and going over a cell phone. Okay. Well, I'm going to wait for MacKenzie to give me the thumbs up. But does anybody else have anything they want to talk about before we start?
I'm almost ready. My thing keeps throwing an exception. I have no idea why. Woo!
That's okay. Second. We've got a lot of people ready to banter about stuff.
You've got test and prod, don't you?
I had a nice little environment all up and running, and then Ben was like, "Oh, you should change the aspect ratios to make it look better," and then now nothing works.
Blame it on Ben.
Nothing is working.
Jim, you had something to say?
Yeah. Is anybody on the video not from Columbia?
I live in Aiken, South Carolina.
I live in Asheville, North Carolina. I'm that guy from Asheville.
We've got a couple that are nearby. Yes.
All right.
We're all over the place.
Give a mention that Jace and I partially communicated this over the Hack Greenville Slack, which has been around for many years, but we've having a lot of conversations about trying to bring back face-to-face meetings in Greenville. A ton of them are inactive. So if you're an organizer or you're an attendee or you're in and around Greenville and you're interested in what we're working on putting back together, head on over to the Hack Greenville Slack. It's hackgreenville.com, and there's a join Slack button there. Olivia's been a big part of these recent conversations, and if you go on there, you can just reach out. My handle is Allela, Allela, and I can connect you with some of these conversations we're having about bringing the meetups back.
Is there a particular channel?
The meetup organizers channel has things particular to what the organizers are talking about. There's a thread that's pinned to the random channel that give you the backstory on meetings we've had and conversations. So,
okay.
But a lot of potentially big stuff going on and planning what we could do to restore the many dozens of groups we've had over the years that have fallen away.
Thank you, Jim.
I'm turning off my video to save bandwidth.
I can attempt to piecemeal this together on the fly.
Yeah, I think I can add on to that. I think what we're also planning to do with the Hack Green. Oh, okay. I have audio. What we're also trying to do is also like kind of collect all the groups a little bit more, centralize them, so we can like help with funding and like advertising or marketing kind of, and hopefully we can like help revitalize, connect companies with groups and stuff like that. So
That'd be great.
Yeah.
We can have beer and food, and everybody won't be fighting over the same 10 speakers and the same 10 sponsors. At least in theory, that's the angle we're going with to figure out how to move forward with some of these groups.
Are y'all able to hear them okay?
Or can you hear?
Ben,
I'm sorry, what was that?
were you able to hear them okay?
Not really, but it might be you.
Okay.
It might be my connection. I mean,
Jason, I was
my
able to
connection
hear
right
just
now is
fine.
green, but it's only green just means good. It doesn't mean fantastic. I think. I guess it means good enough. But you guys have the best. You got the best bandwidth of anybody on here.
Yeah, well, we're connected by fiber, so right?
Yeah,
I would hope so. Yeah.
throttled to like 5 megabit. 5 or 10.
Wait, actually, I take it back. Robert he's screaming along at 1 meg.
Get one.
Yeah, if y'all couldn't hear Olivia, do you want her to repeat?
Yeah, go ahead, please.
okay. Okay. Can you guys hear me? Okay.
Now we can, yes.
Yeah.
Okay. Yeah, so I wanted to add on, I guess. So the thing we're trying to do with Hack Greenville is like use the brand name to kind of like centralize all the groups around this area a little bit more. So we could like potentially bring back groups that were kind of inactive and like have combined meetups with other groups, and that sort of thing if organizing is too much. And then we can, we're thinking of having like centralized places for donations. So companies can easily donate to multiple groups or like make it easier just for them to contribute and get their name out while also supporting all these groups. So maybe we could, have like combined parties where we have like, pizza and drinks as we do like meetups and stuff. So, yeah.
That's fantastic. Really, I think that's something that's been needed for a long time, especially since the pandemic, but yeah.
Yeah, so conversations like that are happening in the Hack Greenville Slack. It's also, you can look at stuff on the Hack Greenville site if you're unaware of it, but that's kind of the upstate area, so not so much like the coast or whatnot.
But if you like it down there in Columbia, it's all open source, so we'll glad to give you our GitHub repos.
Sure, yeah.
You can copy it all.
Okay, I'm ready now. And if anything doesn't work, I'll just blame it on someone else, or the deep state or something, and we'll move on.
Yeah.
And if I lose power, it's because I just started hearing thunderstorms outside my house. So if I drop, that's why. All right, are we ready?
We're ready.
Okay. Hello, everyone. My name is MacKenzie Morris. I am a member of the Columbia Security Group. I work in cybersecurity that Ben attends. And we were just chit-chatting. So, and he asked if I could come talk for a little bit. This is gonna be super informal, and I just wanted to come talk about some of the stuff that I do and some of the interests that I have, and maybe see if you guys are interested in it. So, I'm a industrial security consultant. I used to be a chemical engineer, and then I moved into system administration. Then I moved into cybersecurity. So I do cybersecurity for like the power grid and oil and gas and manufacturing facilities. And now I work for Dragos, which is a startup company. So I do a lot of ICS systems, and that's basically like my bread and butter. I do all ICS, and ICS is really cool, but it's a little bit weird, and people don't necessarily interact with it all the time. So I just wanted to come like give an overview of industrial control systems and sort of show some of the fun quirks about industrial control systems and how like Linux is important in ICS environments, and just like showcase a couple of things for like 30 minutes or so, and let you guys be horrified by the fact that like our entire world runs off this. So like
I'm sorry, MacKenzie. ICS is what?
industrial control systems.
Thank you.
So yeah, so there are a couple different terms in acronyms because like most of the industrial control system space is all like former military. It's just littered with acronyms. There's like industrial control systems and operational technology, which is the same thing. And then there are SCADA systems, which stands for supervisory control and data acquisition, and distributed control systems, which are also the same thing. So like half of the terms mean exactly the same thing, but everyone uses them depending on where they're from or what their background is. So when I say ICS, just think like warehouse, traffic lights, automation systems, anything that builds or the other cool term that people use when they want to sound awesome is cyber physical boundary, where like code actually actuates something in the real world. So like a great example of that is for show and tell purposes. This is just like a 6-port analog discrete card. It's just a switch that's soldered on to a simple like PCB. And it has 6 switches that just actuate up and down and can send an IO signal in. So there are 4 things like discrete in and out and analog in and out. So some of those can read in larger values and some of those can only read in ones like I's and O's. And I'll get a little bit more into that later, but I just wanted to show you. This would plug into, here we go. Sorry, I have things on my desk. This is a PLC. It's a really small PLC. It's a Velocio ACE11. So it's a simple PLC. You can program it to do stuff around your house, like run your coffee maker, open your garage door, turn your sprinklers on. It has inputs and outputs here. So it can take 8 inputs. It's not currently powered, but see, like you can plug it in and you could have it somewhere and you can flip things on and off. So if you wanted to, you could like have a home automation system with this PCB board. You could put the output to a wireless card, and then you could program this to open and close like your doors or open your garage or anything like that. And I'll get into PLC programming and how that looks in a little bit, but this is the operating system that's on this is like a derivative of Linux called VxWorks, but that's not necessarily what we're going to be talking about today. But pretty much all PLCs are running some sort of Linux operating system that like their vendor forked off of something a long time ago. So this is like a really cheap PLC. It's like $30 or $40. This is a much larger PLC. This is from my garage and home lab, but also on loan from the University of South Carolina in Aiken. This is a Modicon M580. This is more going to run like a manufacturing arm for like a car, and can take a ton of IO points. So while this can only like control 6 or 7 different in and out like inputs and outputs, this can do like 40,000. So it's a little bit more beefy. It's like comparing a tricycle to a Ram truck. So CPU, you interact with it because it has something called a NOC card. It's network card, and this backplane is really small. So it only holds 4 cards, but they can be like 32 card long backplanes. And this is another input output. So instead of it being switches, these are all wires. They've been cut from its previous life. But this is a 32-point analog input face, and it slots onto the card in the backplane. So all of the communication happens like with a proprietary protocol on the back end. But basically, these are the devices that run the entire world. And when it comes to the OT environments, it's about 50 times larger than the IT environment for endpoints. Also, if anyone wants to jump in at any time, just feel free to like have a conversation or like ask very specific questions. Otherwise, I'm just going to keep rambling about ICS and PLCs and stuff until my time's up. So, so this isn't hooked up for anything. This would use like a TCP protocol rather than a serial protocol to communicate with things. But at the end of the day, like all of the signals from the computer that like tell things to happen will eventually go through this card, and this card will have these wires will physically actuate things in the real world, and that's where like the term cyber physical comes from, because computer code actually sends electrons across the wire that move things in a very particular way, which we'll get into in a moment. So, whoop. Try not to drop everything. So now let me see if I can share my screen without breaking my computer again. Whoop. All right, cool. So we'll just ignore this and drag open. Just a quick thing about protocol. The funny part about like the internet, which I'm sure many people are aware of, is that when it was designed forever ago, back in the 70s and the 80s, and I guess it's continuing to be designed today. We never really changed anything. We just kept adding on to it. And the OT space is pretty much the same thing. A lot of these protocols existed before the internet existed. So you could think of like the Turing machine as the first OT or like industrial control device because it was a cyber physical brain. So people came up with their own protocols. Modbus is like a really common one, which will be the one I'll be talking about a lot today. And they basically created this little protocol that just says like read the values to me, and I'll tell you if you need to change them. So when we got really fancy and added like Ethernet and IP and all these other networking things, rather than change that, we just wrapped the serial protocol in a TCP header so that it just like basically uses every single OT device as a gateway. So it just goes serial into TCP and then back into serial. And that's how we do all our communication. And the fun part about that is that there is no authentication and there is no um, like checking or integrity. PLCs pretty much will take any signal that you send to them as long as it's addressed correctly. So if you have the IP address or a connection to a PLC and you know the address space and whether you're going to be sending in like digital inputs or discrete inputs, you can just send it a signal and it will change it to the values that you have as long as it's not breaking any of the internal logic to the PLC, which is horrifying, but also really fun and cool. So that will be like that was what I was testing that wasn't working while Ben was doing a wonderful job vamping for me. So I think on my other VM I have the programming for I have another PLC underneath my desk actually plugged into my computer, but the cable's not long enough, so I brought this demonstration one. So a great example of this is sort of what the logic inside the PLC looks like. If it looks like it's programmed really like a child did it, it's because that's how these things are programmed. You can get a little bit more in depth in it when it comes to like functional block diagram programming or ladder logic, but essentially it's just a loop that runs indefinitely over and over and over again. And once it starts, it just does a bunch of race conditions to the end and then starts all over again. So this PLC has its states programmed to essentially run like a couple intake pumps, run a mixer, and then do like a flush at the end. It takes like 15 seconds to run this control loop, and it just continuously does that forever. And this is the logic that goes inside of the PLC. And once you program the PLC, it doesn't need a computer to operate. Like it's its own little computer. For example, like if you ever wonder why traffic lights take forever to do their cycle, and why they might change the cycle because like you're trying to take a left-hand turn, but it never gives you the arrow for a left-hand turn. That's basically what we're looking at right now. Is it runs through the loop of, eastbound traffic, northbound traffic, and then it only breaks for left-hand turns when there's a person in the left-hand lane because the laser signal picks it up. So basically, when it hits a state condition, it will say, is there a person in the left-hand lane trying to take a left-hand turn? If there is, like we're gonna make sure that the next time we switch to eastbound traffic, we're gonna have a left arrow, which is pretty cool. So this is what a PLC looks like underneath. The way that we interact with PLCs is something called an HMI, which looks like this. So this is my PLC is currently plugged into it and it's paused. But an HMI, which stands for Human Machine Interface, is like our window into PLCs. So most HMIs are just windows or like computers that have software on them. And if it's not a Windows computer, it's going to be a like embedded device that is mounted on a wall or like a touch screen. Like if you think about someone like at a warehouse with like a control panel in front of them, like physically touching things or like turning on off buttons, or there's like the giant red button, all of that would be considered like an HMI. So as we like look at this little like HMI that's been created that's based off of the code we saw behind us, you can see that it like turns on pump 1 and then it turns on pump 2 and 3 at the same time, and it like has this nice little arrow that runs around, and we have buttons that we can press that like will flush all of the liquid out of our virtual tank. Not that my PLC is plugged into anything, it's just on my floor, but it's sending out electronic signals. So if we hooked up wires to it, it would try to run this system. It believes that it's doing this. It doesn't have any feedback because it only has outputs, so it has no inputs. But the way that these systems are programmed, they go in and out. So that's sort of like what a visual aspect looks like. And the reason I wanted to just give like a little quick overview of HMIs and like the human machine interfaces and how PLCs work is I just wanted to showcase like a Linux distro that I don't think many people have seen called Control Things, which is like a Linux. I think it's a fork of Samurai FTW, which is like a fork of Kali, I think. But basically, it's a Linux distro that has a bunch of tools for interacting with like COM ports and serial connections and protocol dissectors for like Modbus and a bunch of other tools. And I just wanted to like showcase like 2 or 3 of those tools and point you to the web page if you wanted to go look at the tools or get like a better idea of it. All right, so back to Control Things. So I blew up my resolution, which blew up my VM and had to be restarted. So that's why it took a little bit in the beginning. So let's put down Grass Marlin. To give you an idea of where did my Modbus go? I wanted to show you what what these protocols looked like and why they're so dated, I guess is the correct term. Okay, so this is a plant PCAP from like a hypothetical plant, also known as a cyber range, up in Maryland. So it has a couple different OT industrial protocols that are all wrapped in TCP. So the way that Modbus works is there are 40,000 Modbus registries. 0 through 10,000 are all discrete in. 10,000 through or 10,001 through 20,000 are discrete out, and then it goes analog in and analog out. The protocol is not smart enough to read points. So if you want like 0.3 and 5 at the same time, you have to tell it to start at 0.3 and read 4 values or 3 values because it can only read in blocks, and it can only have a reference number of where to start. So the reference number is where it starts in the stack of 10,000, and then the word count is like how far it goes. So to give you an idea, we like sent out a Modbus query, and then if we go down here, you can see that we just read all of the discrete values from the bottom, and they just come in forms of like 0 to, if it's an analog value, it's 0 to 32,000 and whatever the 8-bit U8-bit value is, or 16-bit value is, and then if it's discrete, it's either 0 or 1. So those are the only options. And the way that it works in the real world, when you hook this up, those larger values, you set a range between 4 and 20 milliamp, and the values on the computer correlate to the amperage that travels across the wire, and that's how you do like larger than just on-off signals. So the protocol is not super secure. None of the protocols are secure. There's like 85 proprietary, commonly used protocols, and then there's a bajillion protocols that people just made up on their own, because sending electronic signals across the wire isn't like a super novel concept. So there's a ton of one-off protocols that like only apply to one product or one industry, or were developed by one guy somewhere because you could do this and then tack on something on the back end. So it makes doing a lot of network forensics or cybersecurity really difficult when you're parsing through protocols that make no sense. So let's look at some like cool tools. Grass Marlin, I don't know if anyone has ever heard of it. It's like just a fun mapping tool where you can dump in PCAPs. It'll generate a map for you. It's really common for use in industrial control systems. It comes native on the distro, and it like you just drop in PCAPs and it gives you all of your networking information, how many hosts are in each subnet, and what those subnets might be, and shows you all of the connections that happen between them, as well as some information about the hosts, whether this is like an ABB or a Honeywell or a Carrier like air conditioning unit. I should note that I think the plant one information, the PCAP, is actually is it like a backnet environment? So you can like hook up to your building automation system, or like, which is what backnet stands for, what building automation control, and you can like change your air conditioning or the temperature on like the facility air conditioning, which is super fun. Also a super insecure protocol. So let me no, I don't want to save this. So let me show you like the example of this, and this is like the Linux aspect, and then I'll show you where all this lives. So I have a voltage regulator stood up. If you have ever seen like the transformers on telephone poles or in substations, some of those would be relays, some of them might be voltage regulators, some of them might be like downgrading or upgrading current or doing a conversion. It just depends on what's in the box. But a voltage regulator for a house, for example, might set the electricity either at 240 or at 120. And the way that it does this is it regularly measures your voltage, for example, and it has a high value and a low value. And sometimes, like, the PLCs are programmed to basically, once it hits one of those boundary conditions, to do some sort of corrective action to push it back to its to the steady state it's supposed to be at. So usually, any point is going to have like 1 to 7 values transmitted with it to the PLC, because all the logic needs to be loaded on the PLC. So you'll have your actual sensor value read off of that you're measuring. You'll have your test value that you're always testing it against. You'll have like a boundary condition on either side that performs corrective action, and then you'll have oh shit scenario boundary conditions on either side that like initiate some sort of emergency corrective action. So for this example, we have like 120 volts is what we're looking for, and you can see that there's a value that's just sort of changing back and forth. That would be the current measurements coming across, and we have a minimum value on either side of 110 or 130. There is no like oh shit scenario on this, but you could imagine that address 5 and 6 might be 100 and 150. Those are the holding registries, and then there's a enable output and override min max. So currently it's not possible to override min max, but because this is a Modbus program, we could basically interact with it as much as we want. So this is locally, this is being hosted locally. Unfortunately, I don't have enough memory to open up another virtual machine, but if we open up another virtual machine, we could just ping it. It's live on the network. It's hosted on a port. So if you can reach the address, you can send commands, and you don't need to be authenticated. So Modbus PAL is a tool built into the distro that allows you it has a, actually, let me run the -H. Modbus PAL is a cool tool built in that just lets you interact with Modbus devices on the network. So once you find a Modbus or any control equipment that can interact with Modbus or that is accepting Modbus communication, you can ping it. There are 40,000 possible addresses. You can just throw it in a for loop and iterate through. So because the person that programs and does the tagging can pick any of the 10,000 addresses for discrete IO. And for example, like this PLC can communicate on all 40,000, but it can only do like 7 signals in and 7 signals out, or I guess 8 technically. But the I could tag this to any of the 10,000 addresses. So sometimes to figure out which address is important, it's a little annoying, but you can just iterate through all 10,000 addresses with a read command to see what is being read, or you can send a Modbus command to it that says, read, start at word count 0 or reference value 0 and read 10,000 words or 10,000 values back to me. So Modbus get is a fun tool, or Modbus PAL, but Modbus get is the command that we're running. So we can, so unit 1, Modbus has like a master slave dynamic. So the first Modbus controller is the master, and then every Modbus controller that's connected to it is a slave. It's a little bit weird, but it's not important. But basically, it's the only Modbus unit at this address. If everything is an independent Modbus unit, they're all going to be masters. That only matters if I was to tag off multiple PLCs off the output of this PLC as their inputs. It's basically a pyramid scheme of control and ladder logic. So I can send, I think it's value 1, right? I can send a Modbus command to this address. Well, let me read it first. I can just read it. Oops, that is the wrong command. I pre-typed these out for a reason, and it's this one, isn't it? Yes. So you could just read it over and over again. The same thing that the GUI on the computer is doing. It's reading the PLC's values that are running on it. I don't think my camera can reach on there. There are lights that are flashing on it. It's not really important because there are these like little lights that flash across the PLC. So we can read the values, but we can also interact with them and write to the values. So an example would be like we could write 240 for the output value, like the maximum output. So on the voltage regulator on the left on the screen, you saw like it switched to 240 because we just said like, hey, I know that you're supposed to keep the voltage at 120, but like, what if you just changed your set point to 240? We can change it back to 120 if we want to like cover up our mistake. We could set it way higher to 300. But maybe we need to like move the boundary conditions, so we can sort of change that too. Should be like 3. We can make the maximum output like 150, so that we can start like trying to push the allow the system to sort of like run by changing like the boundary conditions, just because it's all sort of sitting there out in the open. Modbus PAL is the program. I think I had one more thing I wanted to show you guys. Oh, here we go. Oh, control things tools. Yeah, so just I just wanted to like highlight. I know that was like a really short demo, but I just wanted to like talk about industrial control systems a little bit because people don't know about them, and then show you that there's actually a Linux distro and like a GitHub page and all this stuff made for interacting with control systems, because a lot of it's either serial or it's some sort of like TCP wrapper. So there's like a lot of custom built tools for iterating and doing the gateway access for serial connections. So you can also like use it to interact with like actual microprocessors and do like microprocessor like EEPROM dumping as well as flashing and wiping. So there's a bunch of little tutorials and training built in, but just wanted to like show you like a new Linux distro. Sorry, does anyone have any questions? I spoke really fast, but I appreciate the listening.
I
There's
was
also a
curious-
Discord. There's a Discord server.
Oh.
Go ahead.
I was just saying there's a Discord server if anyone wants to join.
Jim has a question.
I haven't gotten into any of this, but I have seen some Raspberry Pi stuff in the years past. Are these tools more for, obviously you mentioned industrial controls, but is this kind of the step above Raspberry Pi, and or do things like control things, tools talk to Raspberry Pis? Are they?
Yes. Yeah. So Raspberry Pis are like they're like a Velocio essentially. They're basically like the lowest level of control in programming. They can run things on loops indefinitely. You can interact with. Actually, I have a like a Raspberry Pi, like something called the Bus Pirate, which is for harvesting like EEPROM and like the microprocessor information. But yeah, so Raspberry Pis you can interact with because like that's what the microprocessors are for like hijacking like microelectronics. So Control Things has all of that in it too, for hardware hacking and like software-defined radio. But it also is for interacting with like network protocols for industrial control systems. There's also one of these GitHubs has like a protocol dump of like a bunch of different protocols for like all Siemens controllers and all backnet information and stuff like that.
I was curious, your command line had, you were connecting to the loopback address.
Yeah.
So are you going over serial on the local host?
Well, so it's hosted. It's just hosted. It's like a web app that's hosted on the local host. There is also a serial connection for this program, but it's just attached to a different VM.
Wait, I have a question too on the GUI you had there.
Yeah.
Printing out the registers. The name and the binding was those stuff you just put in there manually?
This stuff?
Yeah.
Like, oh, did I put it in manually? Yeah, I did.
Okay.
Yeah. So, if you're observing, a like third-party controller that you've never seen before, or that you don't have any controller logic to, this is the information that you would have. Not that you're a power engineer, but it like becomes obvious what it is because, wow, if you run it.
Fingerprinting tools that are sort of like, like port scanning tools know that you're running this if these ports are open. Are there like equivalents for OT systems?
Yes. There's actually a fun one called. Does anyone know what Shodan is?
Mm-hmm.
Yeah, so Shodan does the same thing, but like when it comes to port scanning itself, like you can nmap OT systems as well, or you could just run a for loop to check all possible addresses. Sorry, I don't. Could you say your question again? I think
I guess, is there like a database or like something you can tell, like, oh, because these 10 addresses are open, that must be a Siemens 123 controller?
Oh, no, that wouldn't be possible. But the Siemens controller will tell you that it's a Siemens controller when you if you just do like a Wireshark off the network, because every controller like constantly spits out like who they are all the time across the network. All traffic is like bound with controller information. You could think of it like the New York Stock Exchange floor. And every controller is like one of the traders like yelling out like, my name is like, I'm a Rockwell Allen Bradley, like control logic 759, and my address is this, and also you need to do X, Y, and Z because like the process demands it. So all of the equipment is like super loud all of the time. So you have a pretty good idea what's going on. And when it comes to like finding the addresses, you could usually just, if you have a network tap, you can usually just get a quick read off the network tap.
So do you not get the programs like in an instruction manual or something when you're working with them?
Do I get the programs in an instruction manual when I'm working with them?
When a person purchases a device, does the manual not have the software with it?
Oh, yeah. So I guess so I mean, every PLC is just a blank slate until you make something out of it. I mean, there's a lot of documentation that goes into being able to use them because you're basically programming mini computers. If I'm working like with a customer, from an offensive standpoint, I don't get any information. If I'm working with someone from like a security assessment point, yeah, I'll like look through all of their control logic, and what we call a tag list, which is dun, 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 dun. Here is I think this might help show you if it can load. Not responding. Okay, well,
As a kind of related question while that's loading, is it, and I'm sure like it varies, but are a lot of OT systems like completely air gapped? Are they connected to like one Windows 98 computer, you know, that's connected to the internet? Or do people hook like, you know, their point of presence internet straight into like the PLC device typically?
That's a great question, and I wish the answer was that they're all air gapped, but that might have been the answer in like 1990. And the answer that most people will give you is that it is air gapped, but at some point, at some time, someone added an internet connection because it saved them a lot of money. So I think we did I think so Dragos put out like what we call like the year in review, which was like an assessment of like 400 companies that we interacted with, and something like 60% of them had like remote connections, and of those, there was like a huge number of them that had more than 7 different types of remote access. Like they have Log Me In and TeamViewer and BombGuard or Beyond Trust, and then they have like their actual authentication mechanism, and then they have like 3 others that they didn't even know that they had. Because like their one vendor that makes like one cutting tool from Switzerland refuses to like use anything other than the I don't know, whatever, like Dispel as a remote access solution. So to answer your question, no. If you go on Shodan, which I guess I could have added as a thing to do, we could like it scans the entire internet for OT. It scans the entire internet for a lot of things, but it explicitly calls out like a bunch of OT controllers. So you can like look at your local gas stations like tank values and their well, or you can. I know that the famous Shodan example is there was a DEFCON talk where they were like, let's play around in Shodan, and they accidentally like logged into a dam's distributed control system, like the HMI on an actual water utility. So yeah, there's a lot of remote access. Oldsmar was the water utility in Florida that got popped because they just had like an open TeamViewer session that allowed you to like control their water utility hanging out on the internet. So there is a lot of remote access and a lot of like poorly administered security boundaries.
Target, when they had their attack was through, I think, a Johnson Controls system.
Yeah, it was their air conditioner or their thermostat or something like that.
Something like that, yeah.
For the person that asked earlier about like the values and the logic inside of PLCs, the person that actually programs the PLC, which is when we see the things like voltage and the changing values, the address that those names are attached to is something called the tag list. The tag list is what lets you set, address 1 through 4 is, the first address is going to be a sensor address that tells me what the voltage is reading as. Set 2 is going to be like a sensor address that's going to be our set point, and then the next 2 are going to be set points for emergency stop. So you program the something called the tag list, where you name them and you give them their purpose and value. So in this example, emergency flush is discrete 6. The like intake pump valves are discrete 1 through 3, and we run mixers like discrete 4, and then the outtake pumps is discrete 5. So like we're assigning each of the discrete points, like the IO points, their own value, and we're enabling them to be remote writable in this case. So we could disable this, but it might prevent our ability to change it from a command line or over the internet if we're not necessarily at the water utility. Most water utilities share like an IT person between 3 of them. So having someone on site at all times might not necessarily be a possibility. So maybe we make it remote overrideable so that we can override it. But all of our usability features are also like huge security concerns. So this is like the tag list is basically where the PLC programmer or the Programmable Logic Controller, I don't think I spelled out that acronym yet, but sets up the tag list to give names to addresses and like what their purpose will be.
MacKenzie, I have a question.
Yeah, sure.
Can Node-RED, which is a Docker containerization programmable interface, can that work with PLC and what you're doing?
I don't know that much about Node-RED. The answer is probably. It probably maybe not with this one, but with the Modicon has an entire web server that runs on top of it. Like this PLC is pretty extensive. Unfortunately, my other computer is out of order right now, but this actually runs an entire virtual factory on it. That's its like job, and it does it all like on a mini closed network. I wish I could showcase that for you guys, but it's all under construction, if you will.
Yeah, Node-RED is something that you can wire together different hardware that is internet aware. You can wire those together in a programmable fashion. You can do that on SBCs using standard Linux. I didn't know whether that worked for PLCs or not.
Oh, it most definitely would then. All PLCs are internet aware, whether they want to be or not.
Right. Because I've used Node-RED before on my Raspberry Pis, and it's a great Docker container program.
Okay. Anything you can do to a Raspberry Pi, you can do to a PLC.
Okay, great.
So basically a perfect stand-in. You can't even. The only issue ever with getting to PLCs is making sure that like there's a protocol gateway, or that you know where serial and TCP exists. The more modern we get, the less of a problem it is, because everything is done like digitally and logically. Only when we're talking about like really old equipment is it serialized entirely. So like if you wanted to go reprogram a traffic light because you're tired of how long it takes for you to do a left-hand turn, you're just going to need like a 12D pin cable or something like that, because it most likely will take only serial connections. But newer cities are putting, like mostly cities, not like a rural environment, but like bigger cities are putting in digital traffic lights that let them change all of their traffic schedules from like one control station, so they can do like massive changes to like help with like traffic flow, rather than having to manually change traffic lights at any given time. So whether that be good or bad.
Yeah, well, Node-RED too is great for like Internet of Things devices.
I was just gonna say, Node-RED's a lot like that flow builder you have there, where it's a visual system. It's based on top of like the Node, like JavaScript backend, but it's a GUI environment that lets people pull logic blocks together in plugins. So instead of compiling down to a PLC, it like runs on a SBC usually, and can make your like Raspberry Pi do a lot of the same things a PLC would do.
Oh, yeah, very cool.
Yeah, one of my questions was, you got the flowchart diagramming or programming thing. Is that the only way to program these things? Or
No, it isn't.
Okay.
Yeah, no, this is like an educational programming. So this is what the program that there are 4 types of ways to program PLCs, 4 primary ways. The first one's ladder logic, which looks like an electrical wired wiring diagram. And the reason that looks like it does and works the way that it does is that the original people that did this screw won't go back in. The original people who did PLC programming were all electrical engineers that like worked in manufacturing facilities that were used to doing mechanical wiring and mechanical like electrical controls, lockout switchgear, that kind of thing. So ladder logic is designed to sort of function the same way that a real live circuit would. Functional block diagram is what we're looking at right now, where you basically have like logic blocks that have inputs and outputs that are delineated by arrows that like exert a will. The most common programming that like looks like I don't know what you'd more call like a classical compiled language is called structured text. And that is sort of like a if then do this for loop, and it runs like a text block. But basically it's just a giant case in like switch statement. So it just runs the same code over and over again. The only problem with structured text is it's the most prone for like infinite loops or breaking your logic. But the entire thing is essentially in a do while forever, or yeah. So just as like an aside. So any other questions? I just rambling.
This is Jim Greenville. Maybe 10 or more years ago, we did a project at my old company with BACnet. You mentioned that. So I'm just curious, what is that primary use? And then the other one is sort of a question / comment is that you mentioned your security focused on this stuff. And then you mentioned all the reasons, physical and digital, that it's very easy seemingly to get into these things, but it must not be that easy because obviously people aren't taking over shit left and right every day. So like, what is the bigger threat, physical or digital, in like being able to get into these systems? So BACnet, and then what is the threat? Those are the two questions.
So yeah, the cool thing about like the cyber physical and the PLC programming is that most facilities have engineering controls in place. So regardless of how much you ramp up the voltage regulator, at some point a physical relay like a breaker is going to open because it gets tripped, and there is no programming or connection. There's a physical breaker out there that like flips a switch at some point that like either the voltage gets too high or the current gets too high, or there's a time delay issue on the power grid. It's just going to open to de-energize the cabling in the tower to protect the equipment. We call them protective relays. So same thing exists in like if it's a tank that's getting too pressurized, it has a blowout valve or a relief valve. If it's a pipe, it has a rupture disc. One of the funny things about, for example, your water system or your water utility is if you've ever gone somewhere and you've seen like a water main break or something like that, and you're like, man, the water main broke, and then maybe like a year or two later, or like 3 years or something happens and the water main breaks again, but like roughly in the same location. And the reason for that is that water piping that's inside of a city is designed to break in specific locations. They like intentionally designed the pipes to be weaker, so that when something does happen and they do have a break, they don't have to go all over searching for it. They already know where it broke because they intentionally designed parts of the system to be weaker so that they know where they go when they break. Same thing for gas lines. So we designed all these engineering controls around so that we don't need to rely on the logic only. The only problem is like once you get to the system, and once you have like established command and control, it is really easy to mess around with it. But knowing the actual industrial process and the controls is really difficult, and you need essentially to be like a controls or an engineer to like come up with some creative way to actually exert some negative penalty, where like a safety system or an engineering control is going to prevent you, which is like why most facilities just get ransomwared. There were like 600 manufacturing facilities and companies that were ransomware last year. And like none of that ever makes it to the news because they just like immediately pay the ransom. They're like super guilty for that because manufacturing runs massively lean. It's one of the most lean critical infrastructure facility verticals. So they just get popped, and then they just pay the ransom for a couple $100,000 because like one down day for them is like $7 to $10 million depending on the facility. So it's not a big deal, and they just pay it and move on with their lives. And that's sort of the status quo currently. I mean, obviously we'd like to fix that. So that's like the security aspect. For BACnet, let me open up a BACnet file to show you. I have all these examples. I think this is a fun one. I think this is a control system. Is this an air? Yeah, this is a Honeywell system. So BACnet is building automation control, right? So it includes like your heating, sometimes your security doors, sometimes your security cameras, your air conditioning unit on the building. But for example, when you're talking about like how do we find out what protocol or like what these values are, BACnet's a super noisy one because here we're shouting out like, here's my property 156 and like I am device 123 and like this is my name and this is my unit and I am a Honeywell device. Like here's what I will accept. So I don't know what your question about BACnet was, but it's just it's a fun control, and you can access it by just like plugging in, like find an Ethernet port in your building maybe that if they're using the same like internet infrastructure or switching infrastructure, like you can just plug in and talk to it.
Okay, like you more or less reminded / answered me that it's more focused on building controls. We probably 10 or more years ago had someone that had put BACnet systems in schools, and they were tracking electricity usage and using it to try to create dashboards for showing energy efficiency gains and that sort of stuff. So this is in my previous life, but I was wondering if it was more focused on electricity, and I guess I've been so long I forgot it's really just a building control system more than anything.
Yeah, it's mostly what do we call it? Balance of plant, like making sure all the air is nice and the heating is on and the things are cool. But it gets a little bit complicated, or like not that the protocol is complicated or that system gets complicated, but just when you have like 15 air conditioning units or something like that. Control things. So, if anyone has any questions, feel free to ask. And if you want to, you can my name is MacKenzie Morris. You can just find me on LinkedIn or something and give me a shout out if you want to talk about more stuff or you want to follow up and ask more questions. Or if you want to give constructive or negative feedback, go for it. Otherwise, I am a member of the Colasec group. So I do that, which is the next Tuesday, I believe. So.
Yeah, at the same time. So thank you, MacKenzie, for a great presentation.
Thank you, MacKenzie. We appreciate it.
Thanks. Sorry, thank you for letting me come and talk. I was just a rambler.
No, it's okay. I'm going to go change the traffic light near the house, so that'll be good.
Yeah, you didn't learn anything too bad from me, so you guys will be fine. This is the beginning of the rabbit hole.
I know nothing.
We definitely never, ever hacked a metro system, so we'll be fine.
Thank you very much. Really appreciate it.
All right. I will. Good luck. Bye.
Bye, MacKenzie.
All righty. So I guess we'll adjourn then, if that's all right, Ben.
Yeah, I'm good. So, yep.
Good to see everybody.
Thanks for stopping by. We'll see you all next month. Oh, we'll see you at the Southeast Linux Fest if you're going.
Yeah, that'll be the weekend before next meeting.
Yeah, right. Okay.
We'll see you.
All right. Talk to y'all later. Bye.
Bye.